Hello students, a very warm welcome to Electrostatics last lecture. It's not even lecture number 25, it's going to be the last lecture of Electrostatics. Hello students, a very warm welcome to Electrostatics last lecture. It's not even lecture number 25, it's going to be the last. So yes, this is going to be the last lecture on electrostatics, and today we are going to get into the last concept of electrostatics, which is going to be the electrostatic potential energy of a dipole system. So we have started our discussion on dipole system. We are currently on that lecture where we are going to discuss how does a dipole system get an electrostatic potential energy or electric potential energy. So this lecture is going to be very interesting, and a very warm welcome to this amazing session. And guys, you are on JEE English by Unacademy, India's leading and largest test preparation platform. But that being said, JEE English is India's one of the first channel where you get all of your lectures full and content completely and exclusively in English for your JEE Mains and JEE Advanced preparation. So students, please do share this video on your social media, WhatsApp, Telegram, Facebook and Twitter, whatever other channels that you have, because someone in need may get access to this free of cost full length quality lectures, guys. So do share it, and do also like this video, and do not forget to click on that bell button and subscribe button to get timely notification. Alright, that being said, we are on the last part of electrostatics, and students, make sure you maintain completeness by completing all of this 25 lectures. Quite important, guys, very important that you complete all of these lectures. That way you will be able to score at least 2 questions in your JEE Mains, and combine it with capacitors, you'll be able to score 3 questions. So that being said, students who know me well and good, I am Murlidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I have filed 25 patent applications in India and abroad, and I have a track record of winning several national level science and tech competitions. So that being said, guys, from tomorrow onwards we won't be having this regular lecture series, since most of you are approaching your JEE Mains exam, which is scheduled to happen in February. And one more important news for you is we are going to get an information on your JEE Main syllabus. I don't know, as per NTA director there would not be any change in syllabus, but still we don't know. So that would be revealed very soon, I believe. Today or tomorrow you must be having that news with you on your new JEE Mains and JEE Advanced syllabus. Only JEE Main syllabus, I believe, from NTA. So stay updated, and we will also keep you updated. But that all being said, tomorrow onwards, from 1st of December, okay, from 1st of December, we are going to get started with new lecture series. So this is to boost your JEE preparation. This is to accelerate your JEE preparation, and so that you can excel in your pursuits. So yeah, that being said, we have 2 separate sessions that will be going on from tomorrow onwards. One would be for 2021 aspirants. So for 2021 aspirants, what we are going to do is we are going to have a PYQ and FYQ series. So what is this PYQ series? In this PYQ series, we'll be taking up questions from your previous year papers. So yes, previous year paper questions is what we will be dealing in this PYQ sessions, guys. So don't miss it out. This is specially made for 2021 aspirants. Get a gist of the model. Up until now, if you are solving the book, this is the session to attempt and to get a gist of how do you approach problems in your exam. Of course, as an IITian, I'll be guiding you on the ways to work around this problem. Hi Suman. So that being said, yes, FYQ and PYQ, definitely more of PYQs and also FYQ. So this would be happening from 7:30 to 8:30 p.m. from Tuesday to Friday. So stay tuned, it will be happening at the same time, and for only 1 hour. All you need to do is dedicate 1 hour for your JEE preparation on JEE English. That way you will be able to get really the understanding of your paper pattern, and also we'll be dealing with the concepts on the along with the problem. So that is always will be the objective in JEE English. So any problem that we take up, we will give you or elucidate the problems around this. Absolutely, Aditya. This is for 2021 aspirants. So stay tuned. Do not even miss out one lecture series. So what do we have for 2022 aspirants? So we are going to take a different approach for 2022 aspirants, since you're almost like 40% through your journey of JEE preparation. So let's say you will be having your exam in the next year, January 2022 January. So we'll be taking an accelerated approach for your JEE mains and JEE advanced preparation. So what we will be doing is we will be taking up model problems, and those model problems are going to be nothing but your concepts. So that way, we don't need two separate sessions for problems and concepts. So we'll be taking up a problem, we'll be solving those concepts, we'll be taking up a problem, we'll be getting to understand the concepts really well. So yes, if it's for 2022 aspirants, it's going to be anywhere around, like the topics of 11th class, like thermodynamics, motion in 1D, rotational motion, etc. And for 2020 aspirants, don't worry, we will also deal with the 2021 topics in the PYQ series. But this might be a good way to get your understanding, or get your this would be like a hand-holding session for you. So in a way, you don't have to necessarily know the concepts. So that is the key part. So with the problem, we'll be understanding the concepts, but typically dealing with the 11th class topics. So but anyway, that being said, even 12th class students can attend this session, because if you're missing out on any concepts in thermodynamics, definitely do attend it. If you're missing out anything on motion in 1D, so yeah, we'll be also dealing with PYQ in this series as well. So this will be happening from 6 to 7 p.m. guys, from Tuesday to Friday. So stay tuned. Again, only 1 hour is all you have to dedicate for your JEE Mains and JEE Advanced preparation. So this is for 2022 aspirants, but I still recommend that 2021 aspirants, given that if you have time, do attend it. So two new sessions will be commencing from tomorrow. That is going to be from 1st of December. Let me repeat it again. From 1st of December, for 2021 aspirants, we'll be having PYQ series, and for 2022 aspirants, we'll be having concepts and problems series. Okay, every problem that you will be having is going to be a concept. So yeah, that being said, so guys, let me get to a quick point around dipole. So dipole is a system where you have two charges, two unlike charges, and these unlike charges have same magnitude. Okay, and they're separated by a very small distance d. Sometimes we denote this with 2l, etc. So now the question arises, what if I place this dipole in a electric field? What happens? So yes, it would experience a rotational motion. Why is this happening? Let's get into this lecture and understand it. It's going to be super interesting, so stay tuned. Why is it experiencing this rotation? Just like what you saw right now, it's going to experience a rotational motion, guys. Absolutely an amazing rotational motion. And be cautious about the direction of the electric field. Right now, the electric field in which direction? From left to right. And if you notice this dipole, it will rotate from in the counterclockwise direction. Okay, it will rotate in the counterclockwise direction, clockwise direction. This point, so this is a clockwise direction, right? So inside it's going to be a clockwise direction, given that the electric field is from left to right and the dipole is placed in this manner. All right, let's get into it and understand more of it. And that being said, guys, Ask Us Anything session will be live on 2nd of December. So post the beginning of the new series on 2nd of December, from 9:30 p.m. our entire, our complete JEE English team will be present, and we will be taking up questions from you. We'll be taking up questions from you, and you can ask us anything and we will be answering that. Okay, and you can as well comment in this lecture series that whatever you would like to know, just type it out in the comment box, guys, so that we will be able to take up your questions. So it's going to be Ask Us Anything session, where you can come up with any kind of question and we will be answering that. And yes, our team as IITians and NITians, head of coaching institutes who have been leading the departments, and of course very good faculty in terms of physics, chemistry and math. So you can definitely attend this session. You must actually definitely attend this session according to me, so that you get your doubts clear. So okay, 9:30 p.m. Do not forget. Not only that, our team is also present on Iconic subscription. Now you can take your JEE preparation, be it JEE Mains or JEE Advanced, to next level with our personal touch, with our personal coaching, with our IIT JEE workshops and expert guidelines and frequent test analysis and study planner. So think about it. You will be able to get all the guidelines from our team on this iconic subscription, guys. So that being said, yes, do not forget to take your IIT JEE preparation to the next level with our amazing team. We will be coaching you on this. We will be personally mentoring you on this pursuits on your IIT JEE preparation journey. So that being said, also Unacademy Combat is going to happen soon, and this is going to be on 6th of December, guys. On 6th of December, again, we will be having this, amazing Unacademy Combat. So what is Unacademy Combat? It is the most competitive gamified JEE battle ever. You can compete live and win lots of rewards and prizes, and this prizes includes hundreds of Amazon vouchers and Apple products like MacBook Air. So think about it, like having a MacBook Air at your home and preparing for your JEE Mains and JEE Advanced. That would be an amazing thing. You can attend, Unacademy lectures from your MacBook Air, and not only that, you can also win lots of Amazon vouchers. But more importantly, it's about your JEE preparation. When you are competing live with such a competitive crowd, you get to understand your standing, you get to learn about how to perform in your test series, how to perform in your exams. So this is a definitely attend event for you. So do attend this event and enroll today with Murli Live Code. It's going to happen on 6th of December. Do not miss it out. It's going to be a super rewarding experience. So that also being said, guys, do download Telegram app. If you don't have one, do download it from your Google Store or App Store, and just click on this link which is available in the description box below. So this link is available in the description box below. All you need to do is click onto this link and you will get onto our Telegram channel. Once you get onto our Telegram channel, what would you get? You will get live before time and up-to-date updates on every class that is happening on JEE English YouTube channel, or any lectures that our JEE English team conducts on Unacademy Learning app. So make sure you are attending these, you are on this Telegram channel and attending all the lectures. Be regular to lectures. That is very important. You can also type in JEE_English to find us on Telegram. Okay. So yeah, this is something also that you can do, but the link is available in the description box below. First of all, do download Telegram app. So yes, and capacitor A to Z series is complete. Let me tell you, today we had almost the last session of capacitors where we discussed a lot of PYQs. So be sure to attend them as well. So we had anywhere around 6 A to Z lectures on capacitors. So yes, do attend those lectures, students. This goes hand in hand with your electrostatics, especially if you have been attending this electrostatics from the beginning. Do cover the 6 capacitor based lectures. You typically get one question. It's easy. And also we have covered like units, dimensions and measurements on the A to Z series. So in this A to Z series, what all did we do for units, dimensions and measurements? We did units based problems, we did dimension analysis, we did error analysis, we did least count based analysis, we did measuring instruments like screw gauge and vernier calipers. So why am I saying this thing when I'm talking about capacitors? Because capacitors, 2021 aspirants know that you need to cover capacitors. So this 6+2 sessions that you have to cover, but many times 2021 aspirants ignore this part. But don't do that, because this is very important for your JEE Mains and JEE Advanced preparation. Let me tell you why. All you need to do is attend this 4 back-to-back session plus 1 model problem session. If you attend these 5 sessions, your JEE preparation is complete, guys. Your JEE preparation in terms of units, dimensions and measurements is complete. We have discussed PYQs, we have discussed all the concepts, we have discussed so many different important physical quantities for which we have done dimensional and unit analysis, and all it would take is 5 lectures. It's quite easy, it's less time taking, not only during your preparation but also during your exam. So do definitely complete these lecture series. 2021 aspirants, 2022 aspirants, I don't need to say that you need to anyway do this lectures. So make sure you attend them. And yes, these were all free of cost special classes on Unacademy Learning app. You can check out my lectures on Unacademy Learning app. And students, yes, as I told you, this units, dimensions and measurements always carries 1 to 3 questions in your JEE Mains and JEE Advanced combined. So not 1 to 3, but 1 question in every paper. That means 3 questions altogether in a 3 session. And also JEE Advanced aspirants, do not ignore this, because you get a combination of questions somewhere around error analysis, etc. So make sure you attend them. It's a definitely asked topic. You can always check out the paper of JEE Mains and JEE Advanced. It has always been asked. You can, you can check out the papers, previous year papers, and it has always been asked. and it's an easy one. And that being said, students, if you do not have Unacademy learning app yet, just do download it from the Google Play Store and App Store. Just type in Unacademy on your Google Play Store or App Store, and the first search result is going to be Unacademy learning app. Click onto this link, install this app. Why you need to have this app handy, or why you need to download this app? The reason is you can attend such many free of cost, A to Z series sessions. You can attend many such lectures from the best educators across the nation. So do follow me, and you will get live updates on every session that is being conducted by me on Unacademy learning app. I typically come on Sunday and Monday from 10:30 a.m. sorry 10 o'clock a.m. From 10 a.m. on your Unacademy learning app. So if you get onto Unacademy learning app, you can start attending other lectures as well. For an example, today there was a capacitor series, and next week we'll be also getting with more interesting topics. And not only that, you can attend national level quizzes. Tomorrow is a quiz day. Tomorrow we'll be having a quiz. So do download Unacademy learning app and start attending these quizzes. They are meant for you. And not only that, students, you can also attend Unacademy Combat. So yeah, many reasons. And that also being said, if you are looking for subscription, it's definitely that you want to download Unacademy learning app so that you can attend the lectures from anywhere and also test series from anywhere. So what do we have in Unacademy subscription for you? We have the best educators across the nation on one platform. That is going to be your Unacademy subscription. Yes, all the best educators have been aggregated on one platform. That is going to be your Unacademy subscription. So you will get to attend daily interactive classes with the best educators in the form of best programs. So what do I mean by best programs? So you will be undergoing an extensive and intensive learning programs for your JEE Mains and JEE Advanced preparation. So this is going to be a structured and a systematic program where every fourth session is going to be a doubt clearing session. That way you are able to maintain completeness and do not have any doubts around the concepts. So concept is the king, students, and you will be able to capture that part of that JEE Mains and JEE Advanced preparation once you get onto Unacademy subscription platform by attending this doubt clearing session. And not only that, we will have quizzes, mega quizzes in every lecture series or in every plus program or subscription program. And not only that, we have national level test series going on Unacademy subscription. So many things I'm telling you, but this is the kind of features and facilities available on Unacademy subscription platform. And more importantly, it's going to be a fun experience for you, because it's on a daily interactive platform where you get to attend those polls, etc. That way I can also see what kind of mistake is happening, and I will be able to guide you in the right way. So yes, that is the amazing thing about Unacademy subscription platform. It's the best platform, best program, and with the best educators across the nation. All you need to do is click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal, and then hit on this get subscription button. And more importantly, Unacademy subscription is not limited by any batches. You can attend as many programs as you want. Let's say you're 2021 aspirant and you haven't covered any topic. We have dedicated programs for you that you can complete. Let's get into that part. Before that, let me tell you, if you are a 2022 aspirant, or if you are in 8th class, 9th class, 10th class or 11th class, this program is for you. Yes, students, a 24-month package is for those students who are preparing for 2 years. It's typically a 2-year long journey. Hence, we recommend to go by 24-month subscription, where you will get to attend the classes for 2 years. And this all comes at a price of less than 2,000. It comes at a price of 2,100, less than 70 rupees a day. So less than 70 rupees a day is what you have to pay for this amazing Unacademy subscription. And how do you get to this price point and get a best discount on your Unacademy subscription? You need to apply Murli Live coupon and avail the best discount on your Unacademy subscription. So that being said, if you're looking for convenient payment options where you don't have to go through the hassle of paying all the fee at once, you can make use of our pay in parts option and split your payments into multiple parts. You can split your payments into multiple parts using our pay in parts option. And we also have access to no cost EMI, which is like easy monthly installments. Again, splitting your payments into multiple installments without any interest. It won't bear any interest. So these are like two interesting payment options for you, which you may want to check out before purchasing an Academy subscription, and if you don't want to go through the hassle of paying all the fee at once. We also have other payment modes like debit card, credit card, UPI on an Academy subscription. And guys, if you are a long-term on dropper, let's say you're a dropper, or if you're a long-term student, or if you are in 12th class, this program is for you. Yes, typically for long-term droppers, this program is for you. This comes at a price of 2,888 only, less than 2,900 per month. So students, what do we have for you? We have, as I told you, dedicated programs, individual programs on each course we're going on. This way you will be able to maintain the completeness. Let's say you haven't covered optics nicely for your JEE Mains and JEE Advanced preparation, you can attend them. And we have lectures going on in multiple languages, and we have 6,000 plus materials for your JEE Mains and JEE Advanced preparation. And more importantly, we have droppers batch, etc. for you. So yes, we have like, you know, hundreds and hundreds of program going live every week. So this is something amazing for, you know, like long-term and droppers, where you get to attend you know, like these kind of droppers batch with the best educators across the nation without any batch restriction. So students, that being said, do not forget to apply Murli Live code to get best discount on your subscription purchase. Hi Sunil, hi, good evening students. Yeah, avail best discount on your subscription purchase by applying Murli Live code. And there are two kinds of subscription. So one is plus, that is what we have discussed about, and there is something more known as iconic. So what is that something more that comes in iconic? So I told you it's something more. You do get India's best educator, the same facilities as on plus, all those live interactive classes, national level test series and quizzes, and those structured programs, along with personal coaching and study planner from the best educators across the nation, and more importantly with IITians and NITians who have previously cracked this exam and exactly know the path to achieve this success. So if you want to, you know, like get in personal touch with a mentor who will be able to, you know, guide you through this process, you can get that on iconic subscriptions. Yeah, I'm talking about iconic subscription, where you can get in touch personally with IITians and NITians who are educators and who will be able to exactly tell you what to do, what not to do during your JEE Mains and JEE Advanced preparation. And guys, yes, you also get other amazing things like, you know, personal study planner and expert guidelines and frequent you know, like test analysis from us. So think about it, you are getting guided by, you know, IITians and NITians, and who are telling you exactly the way to go about it. So a 12-month subscription is going to cost you 50,400, and a 24-month subscription is going to cost you 77,400, guys. So actually from today onwards, the prices are going to be like, I guess 65,000 for your 12-month subscription and 1 lakh for your 24-month subscription. I believe the prices may or may not have been hiked. If it's not hiked yet, do avail it on time so that you can get the best discount. Still, I believe it's going to be a value for your purchase, because you are getting guided from IITians. You are going to get the personal time of the educators, and this would be an amazing experience for you. But anyway, practice and practice only makes human perfect, and we are on the dipole, which is a very conceptually, you know, which is a very conceptual topic, and which is also, you know, very conceptually oriented like topic for your JEE Mains and JEE Advanced preparation. And try to complete rest of the topic. Students, do not forget to share this video. Do not forget to like this video. Definitely do share this video so that someone in need may get access to this quality content exclusively in English. We have started this JEE English channel so that, you know what, language should not be a barrier for your education. And if you don't understand Hindi, this is the place to be. Or if you prefer to learn in English, this is the place to be. So yes, that being said, keep your dreams alive. Since this is the last lecture of electrostatics, some amazing advice for you. Keep your dream alive, students. I often keep on saying this. 2021 aspirants, do not give up yet. Do not think about dropping it. You can think about it next year. Maybe you avail a droppers batch right now, but do not think about it yet. So later on you can think about it. Right now your objective should be to keep that dream alive and work towards your dream, which is more important than anything. Yeah, hi Sunil. Yeah, you should keep your dream alive, and you should be working not only hard but smart. But electrostatic involves a lot of practice. 25 lectures is what we have done on electrostatics. So this kind of full and quality complete lectures you won't get anywhere. So do share it, and with that, this kind of conceptual understanding. Right, let's get into this topic, and let's get started with a very interesting concept. So we'll be slowly getting into the topic, don't worry about it. As you saw in the first simulation, the dipole was rotating. If you remember, it was rotating in this direction, like in the clockwise direction, due to an electric field present, saying that, you know, a dipole was oriented like this. That means what was happening? The dipole was experiencing some torque, isn't it? The dipole was experiencing some torque. So now comes the question. So when would that happen? When it is placed in an electric field. So start working around this problem, students. Okay, start working around this problem. Even if you're new to this topic, don't worry about it. I'll take you step by step through this entire process, because this is still, you know, dipole, but still independent of rest of the dipole concepts. So the torque on the given dipole system with dipole moment P would be given to you. They would not be giving you Q into L or Q into D in a uniform electric field, where the electric field is at an angle 60 degrees to the dipole moment. Why do they say this? Because dipole moment is a vector quantity. Dipole moment, as you can see, is a vector quantity which is generally, you know, given a direction from negative to positive direction. Negative to positive charge. Alright, get started on this problem. Get started, students. Get started. I'm waiting for you. I'll give you maybe a minute to think about it, and let me know what you think about the torque on it and the force on the charges as well. So do you think a charge placed in an electric field is supposed to experience a force? What about this dipole? Do you think they are going to experience any force? Take a moment, think about it. Think about it patiently. Definitely there is a catch in this question, that what is the torque, and with torque comes many other interesting concepts around this dipole. Alright. So what was a dipole? Dipole is like two charges and they have same magnitude, but they are unlike charges. Okay. Alright. I believe we'll get started. You can work on the on your notebook along with me. So that being said, let's now have a look at this dipole. Okay, I'm not yet talking about any angle. It can be any angle theta. For now, let's keep it as an angle theta. I'll do a thing. I'll just choose a very bright color that is visible. So first of all, in electric field, how is this plus Q charge going to experience a force in this direction, which is going to be F is equal to QE. Okay. And how about this negative charge? It's going to experience a force in the left side. F is equal to minus QE, but anyway we have taken that we have taken care of that direction with our vector indication of arrow, so you need not worry about it. So it's minus QE. Now the question arises, what is the net force in this case? If you look at this dipole system, there is a force on minus Q and there is a force on plus Q. If you add them both, what is the net force? This minus Q, same magnitude, right? It should have same magnitude. So any dipole placed in a uniform electric field, this is due to plus Q, what we are indicating over here. Any dipole placed in a uniform electric field would not experience any force. Okay. Now, the question arises, okay, this is going to be like 0, then what about the torque? If you have a careful look at this problem, it's experiencing a torque. Okay. Why is this experiencing a torque? Take the center of this dipole. Let's call this is a dipole and it has a length 2L, and this is the center of the dipole. Now the question arises, what is the torque on this? See, about this center there is, let's draw this. There are two kinds of things that are acting, right? One torque on one edge in this direction, in the clockwise direction, right? This is one tau. And how about on minus q? There is a force. Would that be creating a torque about the center? And in which direction? In the same direction or in the opposite direction? The same direction. Hence, there would be a torque. Even though net force is 0. Okay. Even though net force is 0. What is the torque going to be? On 0. Okay. And we would be calculating torque about the center of the dipole. Now comes the question. Alright, this is a concept in the question. There are two kinds of torque. Alright, okay. Torque. And how do we find out what is the net torque? Net torque, what do you do? Let's get on to the next page. I hope you understood this problem. That this situation where this dipole is placed in a uniform electric field, it would not experience any net force, but at the same time it would be experiencing a what? It would be experiencing a torque. Okay, so now let's get into the problem and start solving the torque. You understood there will be two torques, one torque, the same kind of torque in the same kind of direction. So this dipole should be experiencing, like a rotation, like what you saw in the simulation in the beginning. So this would be C. And how much is this length, guys? This length is going to be like an L. I'm going to call this L. Distance between both of them is 2L. L. So first of all, we need to calculate the torque about the center. So torque about the center due to plus Q charge and minus Q charge, right? Plus of minus Q charge, we'll be substituting the directions as we move along in the problem. So carefully focus on this. So what is torque? Force into this distance. Which distance? For the minus Q charge, how much is this distance? This is the distance, right? This would be like an alternating angle. So this will also be a theta. How much this would be? This would be L sine theta. If this is L, this is a right angle triangle. So how much is this going to be? L sine theta. L of sine theta. Now comes the next question, okay? About this, what is this distance? This also L sine theta, because this is theta. So what is the perpendicular distance? Perpendicular distance for both the charges from the center is the same. Perpendicular distance is how much? It's going to be L. Let's call this as D, L sine theta. Now comes the question, guys, how do we write the torque? You know the torque's equation or torque's formulae, whatever it is, but it's a concept. Try to understand that it's rotating. There is a rotational motion, there is no translation motion in a uniform electric field. In this case, it's going to be force into distance plus of force into distance. Okay. So tau about the center is going to be 2 force into distance. In this case, both the forces are same on plus Q and minus Q. That's why I'm just writing it down as F. And what would be the value of F? F is going to be Q into E, not minus Q into E, but Q into E. Okay. In this case, it would be rather minus Q into E if you take, like clockwise to be negative. Okay. But that is fine. We are just talking about the magnitude for now. And let's get into that point and understand how it all works. So now this is going to be 2 into Q into E into D. It is not D distance between both. This is the D distance is going to be how much? L sine theta. 2Q E L sine theta. We just calculated this torque. This is the net torque on any given dipole system placed in a uniform electric field. A very important concept, students. Literally a very important concept. Now this is the total torque. Okay, and how much is this? Is can we write down this 2 and L together with Q as P? Let me write it down once again for you. Do it something like this. So what I'm going to do is I'm going to keep this electric field separate and sine theta separate and get something like this. So you would be getting 2 into Q into L. What is 2 into Q into L? P, right? Dipole moment magnitude 2 into Q into L. 2 into Q into L into E sine theta. Right, and we can say this is nothing but dipole moment P. Very good, it's P. This is what? E sine theta. Okay, so if you notice this term, what is torque? Torque is actually a cross product of two things. One is going to be your general two quantities. General is force of cross product into the perpendicular distance or the distance between them, or the distance from the center of rotation or the axis of rotation. So now the question is, okay, that's correct, but if there is a P which is a vector quantity, there is an electric field which is a vector quantity, can this torque be written in terms of cross product? It's possible. Okay. Of course, right, it's actually a vector quantity. Right now we are just writing down the magnitude. If I'm going to write down torque this way, so how is this rotating? This is rotating like this. Inside it should be clockwise, and from which direction to which direction? From P towards E. From P towards E, right? Should I erase this? I'm going to erase whatever is written on the diagram, guys. I hope you have copied down this thing. This is going to be P cross out, direction P cross E. This is how it is rotating, and the other side is rotating like this. Just go from P to E, you're getting it. That's it. Which can be written as P sine theta, and you need to find out that K cap depending upon the direction. Now in this case it's going to be like minus K cap. That's fine. You may not write it down, but if you understood this point, this is the most important point, right? So this is the torque experienced by your dipole placed in a uniform electric field. And uniform electric field, this is the torque. Note it down, guys. Note it down. With this we can do the next question. I mean, like this question quite easily. And what is the angle? Angle should be theta. Angle between the dipole moment and electric field. If dipole is placed like this, angle is going to be different. Dipole is placed like this, what is the torque? It's going to be maximum. Dipole is placed like this, what is the torque? Minimum. Okay, I'll get into that point, don't worry about it. As we move to the question, we'll get into that point. So let's now write down the torque equation. Torque is going to be, we are just calculating the magnitudes. PE sine theta. How much is sine 60 degrees? So how much? PE sine 60, it's going to be root 3 by 2. There you go, you got the magnitude. Okay, simple. So it should be all right. Now let me ask you a few questions over here. What if so there can be different scenarios. One is theta less than 90 degrees. Theta less than 90 degrees, you are going to see it's going to like rotate anywhere. It's going to rotate like this. But if theta is less than 90 degrees, how is your PE sine theta? Your PE sine theta in this case it's going to be like minus PE sine theta. Now next question arises, what if this theta is equal to 0 degrees? What is sine theta? Sine of 0, sorry, not 90, I'm sorry, it's going to be 0. 90 it would be maximum, I'll come to that point. 0 degrees. What is sine of 0? Sine of 0 is 0. That means your torque is going to be how much? 0. Okay, what about theta is equal to 180 degrees? How much is sine of 180? Again 0. That means torque should be 0. So instead of like 60 degrees, let's say your charges were placed something like this. You had a minus q over here and you had a plus q over here, and they are in straight line. In this case, the dipole does not experience any torque. Does not experience any torque. Torque would be 0. No rotational motion. No, phenomena for rotation would exist. Now comes the next question. It's going to be, let's say, plus q and minus q. Okay, instead of the earlier configuration, I'm changing plus q to the left hand side and the minus q to the right hand side. Still, if you notice, what is the torque? It's 0. Parallel or anti-parallel to the uniform electric field or to any electric field, parallel or anti-parallel, it does not experience any torque. Okay, does not experience any torque, no torque. And as I've already told you, there would be two such scenarios where it's going to be like, there are a few places where theta less than 0 degrees and theta greater than 0 degrees, they would be experiencing the same torque. But if you understood that the torque is changing with angle, let's say this dipole has started rotating like what we saw in the simulation, and in that case torque is going to change with every theta. Very important to understand. Okay, and let's say theta is equal to 90 degrees. What is happening? Magnitude of torque is maximum. Simple, because sine of 90 is how much? This is because sine of 90 is 1, which is maximum. Easy, guys. Pretty simple, right? So this is how you need to understand the torque. Torque is this much only. Later on, we'll understand more important things, but this is the beginning. This is the basic. High AA, high. So if you understood that there is a rotational kind of inertia in this system, of course it's experiencing a torque. So what is happening? There would be many other mechanical things that would be coming. So next thing is we are going to deal with something very similar to this concept. So try to solve it, stay tuned, and try to solve it on your own. You should be solving it yourself. Okay. So now the question is being asked is the same dipole system, the same configuration, 60 degrees plus q minus q. Now we are asking you, what is the angular acceleration on the given dipole system with dipole moment P in a uniform electric field E? Now for having this, like angular acceleration, this guy should be having certain mass. Charges do have masses. Okay, charges do have masses. It's not that charges don't have masses. They definitely do have masses. The distance between the charges d. How do we calculate this angular acceleration? Try it out. Distance between them is d. Try it out. Speed of light meaning, good question. Why don't you bring this to AMA session? Okay. Speed of light is like the speed of the photons, the way it's oscillating with respect to. Okay, I'll get to that point. There are many interesting concepts around speed of light. Speed of light itself is a very complicated topic. You can think speed of light is like either the photons having some speed, which is like an hypothetical particle. Nowadays it is expressed in terms of photonic wave equation. It's assumed that these photons are traveling at 3 into 10 to the power 8 speed in vacuum, depending upon the medium. Okay. Should we get started? Do you want to try it out? Do you want to take a second and try it out? At least come up with the approach. This is what I say. This is what I say generally. At least try to come up with the approach. That way it will be very easy. Try to get accustomed to the approach. Let's do a thing. Let's get started. See, we know already one thing. For any given dipole system with an angle theta to the uniform electric field, how much torque was it experiencing? TE sine theta. Magnitude of torque, whatever it is, for this given dipole system with two charges plus q and minus q, and this single charge pair, you will be having P sine theta as your torque. If it has torque, and if these charges have mass, won't they have some angular acceleration? Yes, of course. Okay. Won't they have angular acceleration? Yes, they would. How would you do that? It's a simple problem, students. If you remember from your rotational motion, torque can be written as, okay, let's say this is where it's experiencing the torque. Torque can be written as what? I alpha. Alpha is the vector anyway. So we need to calculate I. We'll get from this both equations we can get the value of alpha, angular acceleration. That is it. That is it. Still, can you think about it? Can you think about it? Think about it carefully. Yes, good question. Actually a very interesting question. I'll get to your question. Okay, I like this kind of questions. Do our mobile flash have speed of light? Okay, post this, I'll get into the question. Okay, so now let's do a thing. We need to calculate something known as moment of inertia of the system. Moment of inertia, this distance given to us is d. If you remember, given to us as d, the distance between the charges is d. But what I'm going to do is I'm going to make a simple assumption right now that the distance is 2l, l from one center, l from other center. Okay, sorry, l from one charge to the center, l from center to the other charge. So now how do we calculate this moment of inertia? Moment of inertia, if you remember, it's nothing but mr square. In this case, it's going to be ml square. Okay, but two ml squares added up. They have same masses, right? M and M. So it would be ml square plus ml square. And what is L or 2L? 2L is equal to the D as per our question. Okay, have this and D, one equation, have this and D, second equation, have this thing that we have just written down as 3. Okay. I is going to be due to two masses, one mass this, one mass this. So we will be writing down, let's say m into L square, let's say due to this mass. And there would be another m into L square due to this mass. How much this would be? 2 ml. Your I, moment of inertia, is 2 ml square. Okay, we have 4 such things from which we can derive our final answer. For answer we need 4. For generally to do your question you just need 3. 1, you need to understand that exists a torque in uniform electric field. You need to know the torque equation. Next you need to know how to calculate the moment of inertia. Okay. I'll get to your question. Okay, it's a good question. I can definitely get to your question. Okay. Don't be in such a hurry. So think about it yourself. So one of the students have an interesting question. Does the flash of your mobile phone have speed of light? What do you think? And okay, we have something this. So this is how much? 2 ml square, but the distance is given in not L, but it's given in D. Okay, to alpha. What do you think? Should a mobile camera flash have a speed of light from 1, 2 and 4? Okay. Further, we can just use these two equations to derive alpha that we want. This is going to be alpha is equal to PE sine theta torque divided by I. Basically, this is nothing but torque divided by I, moment of inertia I. There you go. Substitute this in your given question, you'll get the answer. Okay, so we know the angle right now is 60 degrees. So I'm going to do what? Alpha is equal to PE sine 60 torque divided by moment of inertia 2 ml square. Sine 60, how much? Root 3 by 2. This is sine 60. And this is what? This is PE, and this is how much? On the denominator here, 2 ml square. Okay, let's do a small gimmicks over here. Mathematics, a little bit of mathematical manipulation. This should be root 3 PE divided by. So if you see this 2, this makes a 2 square. So can we write it down something like this? My mistake. 2 ml square, right? Sorry, ml 2 whole square. Okay, so what should be your what can be your torque be expressed when you're going to not express in terms of D, sorry, not express in terms of L, but rather in terms of D. That would be PE divided by M into E square. I hope you understood the concept, students. I'll get back to the concept, but before that, let me get on to the question of one of the students. So, would our mobile flash have the speed of light? See, the moment you're clicking, there are some electrons flowing in your mobile. That part is not going to have speed of light. Of course, your flash is light. It would, once emitted out of that semiconductor, it would have speed of light. Okay, you have speed of light. All right, I believe you understood that point. So the moment you click that flash, it's not going to have speed of light because you're just clicking that flash. That controls input has to go in. There's a logic that is running where your, like your internal computer or microprocessor would be consuming some time to do that, process. That's a very little milliseconds, etc. Guys, it's not even milliseconds. I guess nowadays it's like microseconds. And then post that, this control is sent to your flash, which is nothing but a photodiode, and that photodiode receives that command, and of course post that what happens is that flash emits light. Once all those excitation process is complete, and post that, you will be getting your light which is emitted from that, due to that band gap switch where your electron comes down from a higher band gap to lower band gap, and there you go. Then you will get that photons which are moving at the speed of light. So what is this photons, guys? Photons is actually right now, if you take up any course around physics, right, so you will see that you'll be writing down equations for photons. You'll be actually dealing with equations for photons. A photon as a wave equation. So I do know that because I've done courses around quantum optics, but you can it's actually, quantum optics is a very interesting topic. Our lecturer really made it very interesting during our BTech. Okay, let me get into this question and quickly explain what did we do. We wrote down the torque, which you know is P cross E, which is nothing but PE sine theta, and then you have like tau, which is also I into alpha. So these two equations, this is a rotational, just like how you have F is equal to ma. This is an analogous equation to this, where you use, instead of mi, and instead of A you will use alpha. Okay, if you're not aware of this rotational motion equations, then how do you calculate I? I is going to be mr square. Okay, distance from that center, that is r, and mass is going to be m. So here r is how much? L, which is nothing but d by 2. So this is going to be ml square plus ml square, because there are two charges present in the system having mass m and m. Okay, having mass m and m, one m and another m. Okay, so now you got this point, like how we derived the moment of inertia I, which is going to 2ml square. Now what you need to do from these three equations, 1, 2 and 4, we can write down this. I just equated them. Okay, torque is equal to P sin theta is equal to I alpha, and which is equal to 2ml square into alpha. From here we got alpha, that is the like angular acceleration, to be P sin theta divided by 2ml square, which is nothing but torque divided by I, moment of inertia. Okay, so now comes our question where we are 60 degrees. We substituted that 60 degrees, it's going to be sin 60. Hence, what do we have now? P sin 60 divided by 2ml square. Sin 60 is how much? Root 3 by 2. And we wrote down rest of them just like that. P divided by 2ml square. So from there, what you did was like, what I did was just took this 2 and 2, and I said this is basically 2 square, and wrote it down something like this, and this became root 3 P divided by mt square, because the distance is given to us, not L is given to us. Even our answers are given in the terms of D. Okay, answer should be D. Easy. Let's get into the next concept. So now comes a very interesting one. This is definitely the concept that is going to get you a little bit of understanding of the electrostatic potential energy of a dipole placed in a uniform electric field. How much electrostatic potential energy is going to be present in your dipole system? Now you'll get to understand this from this question. Really amazing question, guys. It's a conceptual question. It's literally a conceptual question. Trust me. Okay. A dipole system. Actually, you can try answering this, students. Start commenting it. If you're on live chat, start commenting it. Do not miss out this question. The dipole system, as shown in the figure, just like this, is in a uniform electric field, and it was found that it's in an equilibrium. What is equilibrium? We are talking about rotational equilibrium, where torque is equal to 0 on the system. And what are those two cases? If you remember, there are two cases. Okay. Now it is slightly rotated from the position, and it was found that the dipole system experiences a torque leading to a disturbance such that the dipole never returns back to its original position. Okay, so what has happened is, you have rotated this dipole a little bit, and what you saw is it is not coming back to this mean position or its original position, assuming that the initial position was the mean position. So what should be the angle between dipole moment and electric? Should it be 0 degrees, 90 degrees, 180 degrees, or none of the above? In two situations, it is in equilibrium, students. In two situations, it is in equilibrium. Okay, what are those two situations? I thought you would be getting the answer quickly, but anyway, let me get into the question. So situation number 1, where the angle between, let's say, angle between electric field and your dipole moment. What I mean by dipole is dipole moment. Okay, which is a vector quantity, right? It's a vector quantity. Vector quantity, direction given from negative to positive charge. Okay. So first of all, there are two such situations. So what is equilibrium in this case? Torque is equal to 0. Anyway, force is 0 anywhere in this uniform electric field. So this is the equilibrium condition. Now, the question arises, so okay, it's an equilibrium condition. So, which is that situation where torque is 0? Okay, let's do a thing. Let's put this electric field in this direction. Which is like theta is equal to 0 degrees case. Theta is equal to, let me write it down over here. Theta is equal to what? 0 degrees case. Okay, well, if theta is equal to 0 degrees, and that is that electric field, the angle between electric field and dipole, if I disturb it, is it going to return back to the position or not? Electric field direction is given by this. Okay, I can draw multiple lines. I'm just drawing one line for clarity. So just try to understand. I have something like this, this, and this. Okay, should I be drawing it this way? But not necessary. Minus q, you have plus q, and what is happening? There is an electric field. Okay, let's understand it conceptually. Force like this, force like this. Same force but in opposite direction. How is the torque? Torque is going to be like this. Torque is going to be like this. If you disturbed it by an angle theta, small angle, some d theta, etc., what is happening? The dipole is tending to come back to its position. The dipole is tending to come back to its position. Okay, understood this point? I believe you understood this point, students. Okay, the dipole system is trying to come back to this position. Okay, due to the torque, it is coming back to this position when theta is equal to 0 degrees, and how much? You disturbed it by d theta, a very small angle. I don't think photons is in your syllabus. Okay, we can do a special session on the photon equation, etc. But I don't think photon is in your syllabus. Let me check it out once. But I don't think we have read photons in 11th class and 11th. Okay, so you have disturbed it by angle d theta, but it is returning back to the mean position. It's returning back to the original position. If you did you understand this point? How is this? Like, I disturbed it this much. Electric field is in this direction. Positive charge is experiencing a torque like this. Negative charge is experiencing a torque like this. This will ultimately rotate back and come down over here. So, what does it mean? Theta is equal to 0 degrees. Note it down, students. Note it down. Very important point. Okay, with this we are getting into a very amazing concept. That is saying that if theta is equal to 0 degrees, that is the angle between electric field and dipole moment, it is known as stable equilibrium. It's a stable equilibrium because it is tending to, why this is known as stable equilibrium? Because it is tending to return to the original position. In stable equilibrium, if you disturb it a little bit, it will actually start oscillating. Okay, because there is a rotational inertia associated with it, it will start oscillating, but it is still trying to return back. It is, like the system is trying to return back to the mean position or original position. So it can exhibit something like a harmonic motion. Clear? So our question says, it's in equilibrium and it has been disturbed, but it never returns back once it has been disturbed. So obviously the answer is not 0. Torque is 90 degrees. If the torque is 90 degrees, you disturb it a little bit, it will start rotating. That's it. And now the leftover thing is 180 degrees. 180 degrees is the answer where actually it's in equilibrium. At actually 90 degrees, it's not in equilibrium. Okay. So, but let's understand this concept. So now what I'm going to say is electric field is in this direction, opposite direction to that of dipole moment. Now in this case, how much is theta? 180 degrees. 180 degrees. Let's say you have disturbed the charge a little bit by d theta. D theta. Now what happens? Okay, the force remains as it is. zero net force on this dipole system, which is not disturbing it in any manner in terms of translation motion, as long as it is placed in a uniform electric field. Now the question arises, should it be experiencing, oh my goodness me, that's just my mistake. Electric field is not in this direction but the opposite direction. Let me correct it. Okay, else the question is messed up. Okay, now plus Q will be experiencing a force like this, Q into E, because electric field is in this direction, and minus Q will be experiencing a force in which direction, students? Opposite to that of electric field. It is going to be in this direction. Net force is still 0. Now the thing is, I've disturbed it by an angle d theta. Now what is happening? See, if I disturb it a little bit, the torque, how is the torque? How is the dipole moment? Dipole moment is like this, from negative to positive charge. This is dipole moment. And how is your torque? Dipole to electric field, rotating like this. Going to rotate like this. This one is going to rotate like this. Is it trying to return to the mean position? No. It's not at all trying to return to the mean position. Absolutely, okay. And a very happy birthday. Alright, so it's trying to return to that mean position or not? No, it's an unstable equilibrium. When theta is equal to 180 degrees, after a small disturbance, see, in stable equilibrium you can expect a harmonic motion. In an unstable equilibrium you are not expecting a harmonic motion. Okay. So in theta is equal to 180 degrees, what is happening? It is actually not on a small disturbance. Let me write it down this way. On a small disturbance, d theta, it is not returning on this effect. What is the on this cos, what is the effect? Going to be not returning to mean position or original position. Okay, so what kind of equilibrium is this? This is an unstable equilibrium. This is not a very stable equilibrium, right? Stable equilibrium is where you lift it from that equilibrium position, it will try to come back to that equilibrium position. So theta is equal to 180 degrees is an unstable equilibrium. Easy? So this was your answer. It's never returning back to that original position. It's always trying to rotate in the opposite direction of its mean position due to the electric field being at 180 degrees in an anti-parallel direction. Of course, both are in equilibrium. Both have tau is equal to 0. Even here, if you notice, the tau, net tau at theta is equal to 180 degrees is 0, right? On the system, isn't it? Yes. Okay. On the system, what is the tau? Tau is still 0. P sin theta sin 180 is 0. So this would be 0. But it's not a stable equilibrium. Easy? The answer should be C. Alright. Now comes the question. Okay. Now this time I have given you the a hint around everything that you need to do. Now you need to derive something known as the time period oscillation. SHM based problems is something that you can definitely expect in your JEE Advanced, guys. Most of the times in your electrostatics, they will try to combine the concepts with mechanics. Okay, that too in JEE Advanced. So I would say, like if you're doing this challenge problem, try to think about it as a JEE Advanced problem, but you never know. It can be asked in your JEE Mains as well. I'm not going to say that it's never going to be asked in your JEE Mains. It can be asked in your JEE Mains as well. But generally, this mechanics combined concept where it is executing a harmonic motion, then it would be possibly, like a JEE Advanced question. Okay, you already understood. I told you in stable equilibrium, if you disturb it a little bit by a small angle d theta, it will be executing a harmonic motion due to the rotational inertia. Now, given the dipole system, a dipole moment P is in stable equilibrium in a uniform electric field E, if the dipole system is rotated by a small angle theta like this, as shown to you, like this is d theta, then find the time period of the oscillation, students. How do you do this? You have everything. You have everything, guys. Trust me. You have everything given to you in the question. Don't think about it. Nothing is given in the question. The distance between dipole is d. We have almost done this concept. Okay, if you are not aware of rotational motion concept, not a problem. Try to attend this, concept and problem series. There we will be discussing it. I think even Rohit sir has covered, rotational motion concept. But anyway, for this problem, we don't need that. I'll be anyway covering the required concepts along with the problem. Okay. No, not that. Focus on the class. Let's get into this question. Okay. First of all, it's in a stable equilibrium. Okay, if it's a stable equilibrium, I told you if you rotate it by a small angle d theta, it will execute a simple harmonic motion like this. Okay. So this is like the path, but to be more accurate, it will be going down, then be coming back up from here. We'll go return to this position. We'll return to this d theta, d theta, d theta, d theta, d theta, d theta. It will be like this in a d theta. Again, this will be the plus q. This will be the minus q charge. Okay, it might look different, but this is how it rotates. Depending upon, if you remember, we drew for oscillating dipole. This is that oscillating dipole, guys. This is that oscillating dipole. Okay, so first of all, it's calculated for a small angle d theta. This is mass m, this is mass m. Both have masses m, both are same amount of charges. Now we already wrote few things. First of all, the usual thing we are going to do is like draw the center, say this is distance L, say this is distance L. That way we know what is the moment of inertia of the system, ml square plus ml square, which is going to be 2 ml square. For now, let's keep it as 2L, even though in our question it's given as D is equal to D is the distance between those two charges, so you can say this is the D, but this is how you're going to write. Okay, now arises the question in your mind. I have moment of inertia, but this guy is saying it's going to execute simple harmonic motion. How do I find out the time period? Okay, now the question arises, how do we do this? So see, it's a very simple concept. So what you need to do is, first of all, understand there is a torque, you're going to equate it to I alpha. Okay, from that I alpha thing, you'll be able to derive the time period. Okay, so we'll be moving in two-step thing. One is going to be a moment of inertia. The other thing is going to be, of course, your torque. What is torque in this case? PE sine d theta. It has been disturbed by an angle d theta, right? It has given a small rotation d theta. Okay, now that this thing, this is d theta, that means okay, I'm going to write down that I alpha thing again, but before that, let's do a thing. Let's say this is d theta, sine of d theta is how much? You can approximately write it as theta. Sorry, d theta. Okay, sine d theta can be approximately be written as d theta. So now in this case, can I say the torque is equal to PE d theta? Yes, of course. You understood this point. Okay. Now the question arises. Okay, now the question arises, how do we find out? Okay, this is equal to I alpha, right? This is basically torque. How do we find out the, what are you going to do? Time period. Started from the rotational motion perspective, which says alpha is equal to omega square theta. In this case, it's d theta. So just substitute it as d theta. Okay, this comes from your rotational motion. You can check out the dimensional consistency, everything will be matching. It's not at all a problem. Which says, what is omega, guys? What is omega? Omega is what? Angular frequency. Angular frequency is your omega. Okay. To substitute them, what you need to do is you have two equations here, one over here. So just to substitute both of them and get the, okay, let's do the math. Okay, there is a little bit of math pending. You know, this is going to be like this, this is going to be like this, but there would be a counteraction due to it's not anymore in like rest because you have disturbed it, and there would be a rotational inertia associated with this system after a small d theta rotation. So from both of those 1 and 2 we can write down something like this. So guys, I think this was a simple concept. But yeah, this is, I guess, to the maximum extent where your dipole system can be asked. Hi Cheshwara, hi, good evening, a very warm welcome Cheshwara. So tau is equal to, what do you have? PE. We are not going to write it down as sine theta, but rather as d theta. Okay. How about I alpha? We are going to write down I alpha as, we are going to substitute the value of alpha to be omega square d theta. Now just take out this term and equate and get the omega first of all. So if I write down something like this, I omega square d theta, just a moment, I'm having a look at your chat, guys, but you know what, we won't be able to complete the syllabus. Yeah, okay, good. Okay, no issues. Good, Cheshwara. Good. Stay focused. Cheshwara, try to complete the electrostatics. You have all the concepts in place in our lecture, so make sure you complete them. So this is going to be PE, what? Not PE, potential energy. PE, dipole moment into electric field. Right? Don't think about it as PE, potential energy. That is not at all correct, because we are going to deal with the PE concept. That's why I'm making you aware of this. PE is different from the PE that we are going to talk about. Rather, I'll call that as like EP or something like that, so that we have something easy for our understanding. Okay, so from this equation we can say omega is equal to under root PE by I. Note it down, students. Note it down. This is only possible in stable equilibrium. Stable equilibrium where it does not experience a large rotational momentum or a large rotational inertia, a small rotational inertia, but that rotational inertia is an headache which keeps rotating the system all the time. There omega would be what? PE divided by I. And what was our I? Moment of inertia. Moment of inertia was 2 ml square. Just substituting the value. Okay, nothing. I haven't done anything. I've just substituted the value. Okay. So I haven't written it anywhere. Okay, I've written it over here. You should be writing it step by step. Okay. Electrostatics is all about understanding concepts while practicing it. Okay. Mechanics is something similar, but electrostatics is a little bit simpler than mechanics compared to the kind of complexity that you'd expect in JEE Advanced. Sometimes electrostatics is simpler. Okay, So we know this, and we can see something like this. So our answer is supposed to be in D, if you remember. So we cannot anymore use L. We need to substitute L is equal to D by 2, or 2L is equal to D. And so we'll be writing down L is equal to D by 2 in this case. Okay, if I do that, how much do I get my omega to be? Omega should be, what is omega? Angular frequency, P E, what is P? Dipole moment into electric field into 2m into D by 2 whole square. Okay. Oh, I think that is why we took it as L from the beginning. If you understood why not D, why not D, why are you taking it as 2L? Because calculations are simple. Okay. Okay, easy. Now, yes, students, now what you need to do, of course, there was a 2. So this is going to be PE, and there would be 2 on the numerator. There would be MD square and root. Guys, let me again I'll come to this question, don't worry, but before that, again, what is this omega? Omega is angular frequency, but what do we need to derive for this harmonic motion? We need to derive time period. What is time period, students? This is angular frequency that we derived. We didn't derive this angular frequency, right? Angular frequency. Frequency and time period relation, T is equal to 1 by F. Angular frequency and okay, just a moment, let me write this down again. Angular frequency and time period relation, what it is? 2 pi by omega So this is angular frequency. If you remember, frequency is equal to 1 by time period, or rather I should have written it as time period is equal to 1 by F, because that is very convenient for understanding. So frequency is equal to 1 by time period is equal to 1 by frequency, which is nothing but omega by 2 pi. F is what? Omega by 2 pi. So you'll be getting 2 pi by omega. Okay. No. Focus on your class, Aishwara. Okay. Now comes, what is the time period, students? Substitute the value of omega. Little lengthy, but if you understood the concept, you can do quickly in your exam. Trust me, you can do quickly in your exam. Time period T is equal to 2 pi by omega. And what was the value of your omega over here? It was something like, if I remember, it's going to be 1 by omega, right? It's not omega anymore. Omega is PE, 2 PE by MD square. So here 1 by omega is going to be MD square by 2 PE. If you further condense it, it will become root 2, but I don't think it will be generally given 2 pi to give you a understanding in your exam that there is something to do with 2 pi. There is something to do with angular frequency. They will give you 2 pi. With that, you can kind of intuit, you need to find out angular frequency. Easy. Time period of which oscillation? Of stable equilibrium oscillation. There is no oscillation in unstable equilibrium. Which oscillation, guys? Stable equilibrium. Okay, of course there should be an oscillation term as well. Please write it down. Okay. Understood? Don't memorize it. Don't memorize it. Okay. Of course, students, stay focused. So this is for your stable equilibrium. Unstable equilibrium would not have it. How did we do this? I'll explain. I'll give you a quick review. Very important concept. Could be asked in your JEE Mains or could be asked in your JEE Advanced. Generally, I think this kind of concepts, messing up the concepts happen in JEE Advanced. But dipole itself can be an oscillating thing in stable equilibrium, and it's a very famous concept. Hence, this is quite possible. Okay, if bond exists between the charges won't move. and if you put them in an electric field, it could be a practical concept, right? You place, like molecules that are dipoles and they are in uniform electric field. It could be like a capacitor plate or something. Then this oscillation can begin. Okay, so let's get into this concept again. How did we do this? Step by step, I'll explain you. First of all, if you remember, we did this even earlier, not just now. The moment, I think this disappeared. Okay, all right, sorry. Here's this. So first of all, if you remember, what all we need to do? First of all, derive I. Okay, this is not a step-by-step thing. You know what is I? I is mr square plus mr square. Here the distance from the center is L for each charge and they have mass m and m. So it's mr square plus mr square is going to be ml square plus ml square. It's going to be 2ml square. Then we already derived this thing. What is torque on about the center is going to be P cross E, which is nothing but P sine theta. Here theta is a small angle for which oscillation to happen. So what happened? We substituted the value instead of theta, we substituted to be d theta. And we said that sine d theta is approximately equal to d theta. Right? Tan d theta is approximately equal to d theta. We wrote down, instead of sine P sine theta, we wrote down torque as P d theta. Okay? I hope this is clear. Okay guys, I'm going to call this 0 because we already have 1. So yeah, and this is equal to I alpha. And then I told you something very interesting, important. If you don't know yet, note it down. Your alpha, angular frequency and what? Angular frequency and what relation? Angular frequency and angular acceleration relation. Okay, angular frequency and angular acceleration relation. So it says that alpha is equal to omega square theta. In this case, it's d theta. So alpha is equal to omega square d theta for angular oscillations or angular ascension. Okay, rotational or angular, whatever it is. Okay. Now this, if you know this is just math. Use equation 1 and 2 and substitute. Equation 1, 2, 0. Of course, afterwards that comes 0. So you will be writing torque is equal to P d theta is equal to I alpha, and then you substituted the value of alpha, which is omega square d theta. Okay. Now I into alpha, which is written as omega square d theta, is equal to P d theta. Just extrapolating this equation, nothing else. D theta would get cancelled. Omega square would be equal to P divided by I. If you remember this, it's good, but still I wouldn't say do remember it, because everything is a concept. Over here it should be in stable equilibrium, it should be rotated by d theta. What is the harm in rather remembering this over remembering the final one? Because this way you'll also be able to deal with any of your mechanical questions, mechanics questions. Okay. Alright. Students, focus on the class. So I can say omega square is going to be P divided by, what is this P again? P is what? P is dipole moment. Why am I saying this? Next concept is going to be electrostatic potential energy. You don't want to get confused over there. It's dipole moment, and as you know, E is electric field. Okay. Now I think you have the best in class clarity that its omega should be P under root I. So P under root I can be written from equation 0 or that expression 0, that it should be 2ml square. Again, we need to change this L in terms of D because our question is about D, not in terms of L. So L is equal to D by 2 since 2L is equal to D. Now next comes omega. You're going to substitute the value. You will get it as under root of 2PE divided by MD square. Okay. But what has been asked in the question? Time period. Not about it's not about your angular frequency. We just derived it, and I told you even a hint. If you see 2 pi, probably you need to derive angular frequency to derive the time period. Okay, so time period is equal to 1 by f, which is equal to 1 by omega by 2 pi. So 2 pi by omega is equal to angular frequency. Time period again. Time period. Okay, substitute the value of omega, you will get it to be like 2 pi under root of md square by 2 Pe. What is P? Dipole moment. E, electric field. Okay, so it should be, I guess, this or no. Okay, it should be around this. Okay, all right. So what? This is correct. This here, this 2 is going to confuse, not 4 pi, of course. Okay, but answer should be A. Once practice it yourself, it will be simple. With this, we'll be getting into something very interesting. Now, let's say, you know what, your dipole system, is in a uniform electric field, and you brought it from a stable equilibrium position to 60 degrees. How do you calculate the work? Write out. How are you going to do this question? You have brought a system from stable equilibrium to 60 degrees. How much is the work done? Okay. This was something like this dipole system. And you rotated this by 60 degrees. Find it out, students. Think about mechanical analogy. You will get the answer in the best possible way. Mechanics as your analogy sometimes is very helpful. But of course, this is a different system, that's a different system. But you know what? Sometimes, gravitation is related to electrostatics and during your learning, etc. But I typically try to, decouple them, because that is not the best way to learn, combining your gravitation with electrostatics, both from exam perspective, also from a career perspective. From exam perspective, what happens is, you are not confident saying that, I've seen students saying that, how do I do electrostatics? I don't know the gravitation. Fine, does not matter. And this is not going to work in the future, right? When you're dealing with, let's say research or something, you should be able to do it individually. Don't learn it as a continuation in part, but rather as an individual topic. Try it out. Okay, let's get into this concept. A very important concept: stay focused. Okay. So what did we say? I'm going to give it a color, okay, because that color is going to be helpful in our understanding. Let's say initially it was in stable equilibrium, which means 0 degrees with the field. Dipole moment is at a 0 degrees with the field. This is positive, this is negative, and goes from negative to positive. So this is 0 degrees with the field. You brought it from this position to this position, which is like 60 degrees. So to do this rotation, are you doing the work or the system is doing the work? Let's think about it this way. What did I tell you? I told you in stable equilibrium, it's like that position, which even if you move it from that position, it will come back to that position. So that is kind of the ground level. What do you mean by ground level? Not electrical ground level, but your mechanical ground level. So it's like the ground level. Okay. It's kind of that position in uniform electric field. The stable equilibrium is that kind of position in uniform electric field where your system tends to be in that position with minimum energy. With minimum energy is where you will try to, stay at that position where you are at minimum energy. Think about mechanical systems. If you drop it from a height, you will try to stay at that point. You will come until that point where it is minimum energy. Okay, energy is generally reduced by the system. If you are increasing, it's going to be increase in energy. Okay, let me give it this one guy a different color. Okay, this is position P2. Okay, this is position, okay, not P, let's give it separate names, like because there is already P. So this is A and this is B. Let's say it was initially at ground and then you brought it to one such position. I'm going to mark this with red one. Okay, one such position B where the system has gained some energy. Think about it. Equilibrium, now it can experience a torque due to the existing system. That means you have done work against the system. You have done a positive work. Okay, it's as if, this is just an analogy, it is as if some ball exists, that ball has been carried from position A to position B. Okay, This is just an like an kind of a similar thing that we relate generally, but this is not how it works. Okay, altogether different thing. Okay, but a very good way of understanding things. So ground we assume to be a low potential or lowest potential. In this case is stable equilibrium position. So you can write it down, students. Stable equilibrium, as you understood, should have the lowest position. That is why system as such, the electric field as such, is trying to return it to that position. Stable equilibrium is that point where the system is trying to rotate it to that position, right? So stable equilibrium is that point where system is trying to make it happen. System likes it. Now let's start solving around the work done. If you understood this concept well and good. So how do we do this? So there is actually a catch. Let me do a thing. Let me choose one more color. So initially at 0 degrees, position A to position B, we can't calculate it using the normal equations where we say we don't know, we haven't yet derived potential energy, etc. Else it could have been just difference in potential energies, but we don't know the potential of the system. I mean, like potential energy of the system. We can't do it that way. We need to take a different approach now, but this approach will lead us to ultimately understand the potential energy concept. So stay focused. All right. So that being said, what is the work done generally written in your rotational system? It's going to be tau into d theta. Tau into d theta would be how much? dW, work external. Okay, work external is going to be tau into d theta, right? And you are doing it against some, like an angle d theta, which is going to be in the opposite direction of your tau. So it's going to be minus tau d theta. Writing it down. Just tau d theta, because your angular rotation is in the opposite direction to that of your d theta. All right. So we need to basically integrate this term as you understood and get the final. Okay, and what is tau? Let me repeat it again. What is tau? P sine theta. We just derived that. We just understood this point. This is something that you have to remember. This is not something that you have to derive it all the time. Derivation was something that I did it for you in terms of problem. I told you for SHM you don't have to remember. For a harmonic motion you are supposed to at least only remember a few steps, the process. Rest you need to do. P sine theta is something that you have to remember. Okay. And angular acceleration is something that you need to know how to derive. Okay. Now let's get into this point. Now since you have increased the energy, I'm going to say I've done a lot of work at different theta, because it's as if, okay, let me explain you this point before we dive into this thing. See, you have a system like this at some angle, theta 1, and then you have a system like this at some angle. Okay, let me quickly do a thing. Now write it down over here. This theta 1, some angle. Then this is, let's assume this is the current position, and then what you did was you just a moment, you rotated it this way at some other angle theta 2. Okay, so let this be like okay, in this case this is plus, this is minus, and in this case, of course, as you understood, from negative to positive, I am going to label this as plus and minus. So, but the thing is, at different theta, what I wanted to say is, at different theta, even though I am projecting you with an like acute and obtuse angle, the different theta, it's going to experience different torque. Okay, it's going to experience a different torque. In this case, torque direction. I'm just showing you the direction so that you understand it better. and in this case what it is going to be, like this, sorry, different angles, because it's going to be better. Okay, so what is the torque in position 1? Position 1, it would be, let's say P is the moment of the system, dipole moment of the system. It's going to be PE sine theta 1, and whereas in this case it's going to be tau is equal to, tau 2 is equal to, rather I can call it as tau 2 rather than tau 2 is equal to how much? PE sine theta 2. So different, so tau is changing, okay, tau is changing with theta, tau is changing with theta, isn't it? So tau is changing with what? Theta, angle between dipole moment and electric field. Okay, clear? Is this clear? So we can't just say it's tau into some theta, etc. We need to integrate our dW to find out total work done by the external system, which is going to be minus tau d theta, and in this case we have rotated from 0 degrees to 60 degrees. Okay, for now let's do a thing. Let's keep it as it has been rotated, as you can see in the picture. It has been rotated from theta 1 to theta 2. Like, we'll first of all derive a generalized equation and then move on to a final thing. Okay, I hope you understood this concept. Okay, let's move on. I'm going to basically just mathematically calculate this thing, which is here it would be PE sine theta. Okay, I think we are making a mistake. It should be just be plus, more minus, I guess. A moment. Okay, this should be plus. No worries. Okay, why did I write down the minus thing? Alright. Now comes the final part of this derivation, or this it's not a derivation, it's a calculation. Whenever given, you should be calculating it like this. So sorry, total work done, instead of writing it down as dW, I'll be writing it down as tau d theta, d work external. So this would be how much? What is tau, students? Tau is actually PE sine theta. Okay, PE sine theta. So this integrated from theta 1 to theta 2. Don't assume it to be like for now, don't assume it to be 0 degrees to 60 degrees. Rather, for some time, take it to be like theta 1 to theta 2. Hi Deepak, hi. Okay. So what would this happening, guys? What would this be happening? This total work done. Okay, this is the external work done. Why do I write as D? Hi. So work external, you calculate this. This is going to come out as PE, P dipole moment, E electric field, integration of sine theta d theta from theta 1 to theta 2, saying that this was initially at theta 1 and you rotated it to theta 2 against the system. Positive work is being done. Okay, just correct this thing. Why did I write down tau minus theta? I don't know, it should not be minus theta and all, it's just tau d theta. Okay, so now the thing is just integrating this thing, work external, it's going to be like what is integration of sine theta d theta? What is differentiation of cos theta? It's going to be minus sine theta. So integration of sine theta should be minus cos theta. PE cos theta, theta 1 to theta 2, minus or plus, there should be minus cos. So it would be PE work done by the external force or by you to rotate it from 0 degrees to 60 degrees. It is going to be PE cos theta 2 minus theta 1 or cos theta 1 minus theta 2? Cos theta 1 minus cos theta 2. Lower the theta, lesser is its energy in a uniform electric field. End of the story. Just substitute the value of theta In our case, what is theta 1 and theta 2? It has been rotated from a stable equilibrium position. Okay, note it down. Note it down, guys. Note it down, note it down, note it down. Okay. Note it down. We are almost in the final concepts of electrostatics. Almost what? Almost done. We need to understand one more concept, and post that we are done. Okay. From tomorrow we'll be having PYQ series for 2022 aspirants. We'll be having some amazing series. So be sure to attend them. It's going to be basically 1 hour session only, so you can enjoy them. Okay. And I'll definitely try to bring up problems, that is important. Okay, interesting, of course, also important, because you're preparing for exams. It's not just about learning. Okay, so work done in our case, first of all, what is theta 1? Theta 1 is 0 degrees, which has been stated as stable equilibrium. Stable equilibrium, unstable equilibrium, this kind of things will be used. Do remember that unstable equilibrium, unstable equilibrium, these kind of things will be used. What is theta 2? Theta 2 is 60 degrees, as you can see. So yeah, we need not define those things. So this is going to be PE. So did I say something like during this solution or during this concept, did I say something like 0 degrees it will have the least potential? Okay, I guess the streaming is back. I believe there was a short streaming issue. Just give me a moment, students. Let me check out up until where you had your lecture. I think some part of the lecture was skipped due to streaming issues or something. Yes, we had done it up until. Just give me a second. I'm just having a look at the video to see something has been missed out. I have the stuff out to theta 1, theta 2. Thing has been derived. Very good. What did we have? All right, we are on track then. Amazing. Good. I didn't know that. All right. So I guess there were some technical issues. Let's continue the class. So we had something like this, guys, and what we need to do is we need to basically substitute the values, and from this equation, so you have this amazing thing over here, right? So the stream has begun, so stay tuned, and we'll complete this last topic of your electrostatics, so stay tuned. Yeah. Anyway, so I believe this thing was visible. So let me come back to this thing again. So what I said was, how do we define potential energy? Potential energy is negative of work done by the external system. So we know, we derived this expression just now. We said that work external is equal to PE sin theta 1 minus that of, PE cos theta 1 minus that of cos theta 2. And then what did I say? Negative of work done on the system. So that's going to be minus of change in potential energy. Like what I said, you could have directly written it as change in potential energy is the negative of work done on the system, which is going to be UA minus U infinity, because generally change in potential is written as sum from like you're bringing the charge from infinity to some point in electrostatics. But now in this case we won't be writing it down anymore as infinity. We'll be choosing a reference point. Okay, let me again write down this. So this would be like UA minus that of reference point. All right. So now that being said, how do we move into this thing? So just do take out this equation. So this says, okay, let me get to this. Okay, so we have something like minus of or plus of U infinity. Okay, from this equation I'm writing it down. Okay. UA Okay, minus of u infinity minus of ua. I think change in potential energy is change. It should be like minus. Let me correct this point quickly. It should be minus. Okay, let me quickly have a look at this. Going in the right direction. Infinity minus u. Okay, this should not be negative. This should be should not be negative. This should be okay. We had been calculating this mistake. Let me quickly correct this thing. Let me do a thing. Let me redo this entire thing that we have the best in class clarity, because something as the streaming has gone wrong, etc. I got confused a little bit in between. Let's do it. Redo this again. So what did I say is, so in this case, what is work done by the external system? We derived some equation known as PE cos theta 1 minus that of cos of theta 2. Forget the system, etc. What is that? That is basically change in potential energy. What is change in potential energy? Work done is change in potential energy, right? Let me quickly complete this in a very easy way. Forget the system, etc. Change in potential energy or change in energy of the system. Here there is no kinetic energy, so it's basically change in potential energy. Okay, so now that being said, what is change in potential energy written as? Something like let's call this to be position A. So this is position A. In this case, we say that change in potential energy is nothing but potential energy at position A minus that of potential energy at infinity. That is for generally charges. But here we don't have that concept of infinity for a dipole system placed in a uniform electric field. Rather, we'll be dealing with something. Okay, I believe up until here it's all clear. So just note it down, and we'll move on to the next page and we'll get started with the solution. This is 1, this is 2. Okay, you need to just remember these two equations. Okay, you need not remember any of this, but I'll tell you what you need to understand and remember. Now you need to understand that work done by the external system will change the potential energy with some positive magnitude. Okay. And change in potential energy is generally written as potential energy at that position minus that of potential energy at some infinity position. Okay, here we don't have that infinity position. Okay, or it could be any A to B, but we are saying change in this would give me the absolute potential at A. Okay, this is what I mean by UA minus U infinity, which is going to give me absolute potential at A. That means it is as if the system was at some place where there was no potential energy, then I brought it to some place where it has some potential energy. Okay, that is it. Now comes the next most important concept around this. Okay, the next most important concept. There is a concept, guys. This is a concept that we use in dipole. So we would say that if plus Q and minus Q are placed like this, at an angle 90 degrees, okay, at an angle how much? 90 degrees to the electric field. What happens? We say that, okay, write it down. We say that this position is the reference position. This position is the reference position where we assume potential to be 0, just like your U infinity. We assume this position to be that reference position where the potential is going to be 0. Absolutely, I'll upload this PDF. Okay, don't worry. The stream is going to end. The stream, there was a little bit issue in the stream in between, so that's the reason in between, we got stuck. But anyway, the stream is back. So Cheshwara, stay tuned. This is almost the last question. So that is it. MUSK, yes, we will be getting to that, but I recommend that for electrostatics, don't be dependent upon notes. Be dependent upon your notes, because you need to practice it. If I'm going to give you 25 lengthy lectures of PDF, guys, that would just be like an horrible thing to go through. but rather you should be writing down your notes and you should be practicing it. Okay, so we say that when theta is equal to 90 degrees, what is the theta angle between dipole moment and electric field? If that is 90 degrees, we say that potential energy is going to be 0 at that position. 0 at that position. So it is as if you are bringing something from 90 degrees to some angle. Okay, so whenever I am talking about potential energy, earlier if you remember, it was from infinity, the charge was brought from infinity to that position R. Now it is as if bringing that dipole from 90 degrees to that angle. Okay, from reference position to that of angle. Okay, so now we have two equations which we need to work around. What is that equation? One equation says work done, work external, I'm going to write it down as WE, is equal to PE cos theta 1 minus cos theta 2 is equal to, now I'm going to say something. If I have to find out the position, like potential at position A, is going to be how much? UA minus U90 degrees. So instead of theta 1, you will keep it as 90 degrees. So in this condition, if you keep theta 1 as 90 degrees, that is the reference position, and there you will say potential energy is 0. Reference position, what happens? Potential energy is 0. Like your ground level, even though I have told you, the stable equilibrium is going to have the least potential, you will come to eventually realize that point. Absolutely, absolutely. I will PDF I will be giving it out, but as such, there is no notes for this. But I can put out the notes. Some of the notes are not annotated, but you'll be only getting questions, bunch of questions. I tried to take it in a concept by problem approach. Yeah, you need to write down the notes. Go through every lecture and write down the notes. Okay. So yes, if you understood this concept, rest is easy. What I am going to say, that's it. That is it. This is how you derive the potential energy. Substitute theta 1 is equal to 90 degrees. So let's say instead of 30 degrees, this was some theta. Okay. Then what you are going to do is, you are going to write down something like this. From this equation, I am writing it down. Let me call this as equation number 1. Okay. From equation number 1, I am going to say that at my position theta, instead of theta 1, I am going to put theta 1 is equal to 90 degrees and theta 2 is equal to theta. Okay, the position at which the dipole is. From that position, if I substitute cos theta 1 is equal to 90 degrees, it is 0. Cos of 90 is how much? 0. So this is going to look something like this. Okay. UA minus U90 degrees is equal to how much? PE cos of 90 minus cos of theta. Okay, it's little external. I'll write it down again, don't worry. Okay, this is just for understanding. I'm substituting the value of theta 1 and theta 2. I'll write it down again, don't worry. Okay, theta 2 is not 0, it's theta. Okay, so from here we can say, focus students. Potential energy at position A. I don't know yet, it's 30 degrees. We will substitute that 30 degrees later. Potential at some angle theta is going to be how much? PE cos of 90 degrees minus that of cos of theta. Why didn't I write the 90? Because I said at 90 degrees potential is 0. Hence, U theta minus U90 is going to be just U theta. Okay, this is just an assumption. This is just a reference place, like how we take it to be infinity. Here we take it to be your 90 degrees. Okay, so now end of the story. Why it is end of the story? Because cos 90 is 0. That means U theta is going to be how much? PE minus PE, because 90 is 0, going to be cos theta. If I further write it down, this would look something like PE minus of cos theta. So for any angle, how do you derive the potential energy of a dipole kept in a uniform electric field? It's going to be minus P cos theta. This can be further written as minus P dot E. Minus of P dot E. Not, because P cos theta is dot product, right? So what have I done? I've just written the dot product part. Let me write it down again for you. So it is going to be minus P dot E. That is your potential energy of the system, dipole system, given at any position theta, because you took the reference 90 to be 0. What is this? Potential energy. It could be different in your question, like take the potential energy of 0 to be like theta is equal to 0 to be 0. Then in that case the thing will change, but that would not work logically, because still your cos of 90 is going to be 0. Still that would work, yeah, that's going to work, yeah, I believe that will also work. Okay, it can be given for different angles, so it will become minus of P. Okay, all right. So this is what potential energy of your dipole, potential energy, electrostatic potential energy of your dipole system, of your electric dipole kept in an uniform electric field. Electric dipole kept in an of your electric dipole kept in an uniform electric field. In uniform electric field E. Uniform electric field E. That is it. That's all you need to know. End of the story. So, if at all, in this case, okay, we don't have space, but I'm just going to, I remember this equation. I'm going to directly write it down. Okay, I'll also come to that point. We had to have a discussion where, let's say, if it's 0 degrees, we still call it to be the ground level. Does it have the minimum potential? So U at 30 degrees in this case is going to be minus PE sine 30 or cos 30. Cos 30. Cos of 30. If this is cos of 30, how much is it going to be? Minus PE by 2. It should be A. It's not PE by 2, minus PE by 2. You'll understand that thing once I'll give you an intuition of something. Okay. I'm going to erase this. You can note it down. You can rewind the video a little bit after the video is, the streaming has ended. But I need to give you a very important concept around this. Since we derived this, all you need to remember is this thing, guys. This is the star equation. And let me get to how did we get it from the work done? We take 90 degrees to be 0. If 90 degrees is not 0, if 0 is 0, then you need to walk around the entire thing. Okay, but in our solution, we said that u of theta is equal to minus PE cos theta. Does that mean what is your potential at 0 degrees? Minus PE cos of 0, 1, that's it. Is this less than? So I told you this is going to be at 0 degrees. If your system was like this, at 0 degrees, your system is going to have lowest potential. Okay, lowest potential. Is that true or isn't it? It's true, right? It's correct. So 90 degrees at 0. This is still less than U90 because this is less than 0. Okay, I mean this is less than 0. It is less than 0, but this is less than 0, so it is less than 90 degrees. So you understood from this point, just because U of 90 is taken to be 0, we did not violate anything. Okay, U of 90 degrees is still greater than that of U of 0 degrees. U of 90 degrees is going to be greater than of U of 30 degrees. We got 30 degrees to be minus PE by 2. If you notice beyond, let's say something like theta is equal to, let's take it to be like 120 degrees. How much do we get that to be? U of 120 degrees is how much? It's going to be minus PE cos 120, which is going to be minus PE cos 120. How much is cos of 120? It's going to be minus 1 by 2. So this is going to be PE by 2, positive. So you understood a very important thing. What is that? For theta less than 90, your potential energy of the dipole kept in a uniform electric field is, for theta less than 90 degrees, the potential energy of the system, dipole system, in this configuration, that is dipole moment should be in this direction. Theta is the angle between dipole moment and electric field where dipole is going from negative to positive charge. And what did you have? Theta to be some potential energy to be negative, and minus P is the least possible negative potential energy. Thus at stable equilibrium it has least potential energy. Thus it is that stable equilibrium position. Thus it is that stable equilibrium position. Thus U of 0 degrees is that stable equilibrium position. And if you notice, what is U of 180 degrees? It's going to be P. That's the highest potential energy. Thus it is that unstable equilibrium position. Okay. So this is positive greater than 90 degrees. This is negative greater than 90 degrees. You will see it to be positive. And of course, as you know, we took 90 degrees to be 0. If theta is equal to 90 degrees, it would be, potential energy would be 0. That is it. End of the story. That's it. Okay. If you wanted to check it out for theta is equal to 180 degrees, you can substitute it in this equation. Theta is equal to 180 degrees. How much is your U at 180 degrees? It's going to be minus P cos 180. How much is cos 180? 180 is minus 1. So this is going to be PE. So maximum. So your system would move from which direction to which direction on its own, from higher potential to lower potential. Isn't it true that at 0 degrees it does not move because it has the least potential? Whereas if you disturb a little bit at theta is equal to 180 degrees, even it's a, like an equilibrium, but it's an unstable equilibrium. Even if you disturb it a little bit, it will start rotating. Whereas at other angles, it will try to come to that least potential, which is not 90 degrees, which is but a 0 degree. 90 degrees is for our reference. Okay, it appeared attractive from this equation that we have. Hence, we took it to be 90 degrees. Okay, otherwise, your 0 degrees is the least or the lowest potential point. Every such single point on disturbance is trying to rotate to that 0 degrees. Okay, I believe you understood this point. What I'm saying is 0 degrees is the least potential. We just proved it. It's minus PE. Okay, minus PE. So that is the least potential. Okay, do you have any other place to write it down now? Okay, anyway, all right, we have one more interesting question to go on. Post that we'll be closing this lecture. But yeah, you can write it down. Okay, I'll just dictate it. So whenever your system is kept at an angle theta, it will try to come to 0 degrees. 0 degrees as the least potential energy, which is going to be how much? Minus PE. If you assume like U of 90 to be 0, you assume U of 90 to be 0. Okay, and U of 180 degrees is going to have the maximum energy, which is going to be minus PE cos 180, which is PE basically. So always your system will try to move from higher potential to lower potential, just like that ball analogy, right? Like that ball analogy. Okay, here you have done the work. If you have moved it from a lower angle to a higher angle, that means you have done the work. Hope this is clear. Okay, all right, this is that star equation you need to note down. This is that something that you need to understand. Rest is fine. 0 least, always trying to come to the stable equilibrium position. All right, let's get into the next question. It's an easy question. We'll quickly close this lecture after this question, don't worry. So the dipole system as shown in the figure is a uniform electric field and was found to be in a stable equilibrium. It is given an initial angular velocity such that the final potential energy was found to be 0. Then find the initial angular velocity of the system. Let's get started. What kind of question is this? What kind of model problem is this? This is conservation of energy. Conservation of energy. To give you the best understanding of what we have learned now, this is the model problem that you need to do. Get started on this. Start working on it on your own or by yourself. That is when you will understand it. So what is happening? It's at a stable equilibrium position. You have brought it to 90 degrees. That is where the potential energy is assumed to be 0, right? So at theta is equal to 90 degrees, we took potential energy to be 0. So now it is brought to the final position of 0. What is that initial angular velocity that you should have given so that it is going to come to 0? Involves all the concepts that you have done until now. But basic one. Conserve the energy. Should we get into this question? Only 3 options are given to you. You get the right option, amazing. You understood each and everything except for the SHM part, do it again. Okay, so what is being said? Initially, the system is placed in an uniform electric field. Moment. So the system is placed in a uniform electric field, and what have you done? You have rotated this dipole from this position, 0 degree position, to a position like this. Now arises the question, how much is the angle between electric field if electric field is in this direction? Dipole moment is, let me use a different, at least arrow color for this dipole moment direction, going to be 90 degrees. Okay, what happens at 90 degrees? We say that potential is 0. So some initial angular velocity is given such that this dipole system rotates and comes to this position. How do you do this question? So at position 2, what is the total energy? Okay, let's call this as position B. This is B. This one, which is parallel to the electric field, where dipole moment, as you can see in green, is parallel to the electric field, we are going to call this as position A. So can I say something like this? Energy should be conserved. Energy at position A. Okay, it's not electric field. How do I write down energy? Okay, energy E. Okay, not electric field E, energy E. Energy at position A is equal to that of energy at position B. What is energy at position B? Potential is 0. It has come to rest. Okay, it has come to rest. So how is this possible? Energy at position B is 0. Okay. Final potential energy of the system was found to be 0. That means it has come to rest. Okay, potential energy is 0, but it has come to rest. That has not been explicitly told to you in the question. Some initial angular velocity has been given such that potential energy becomes 0. Why am I saying 0? Because 1, we said it is at rest. 2, potential energy at 90 degrees is 0. Okay, potential energy only at 90 degrees is 0. And the kinetic energy was also 0 at 90 degrees. Okay, this is not explicitly told in the question, but we said we are seeing this in the final position. Final position, probably it must come to rest, right? So now the situation is such that your energy at position A must also be 0. Why not? Can it be 0? Yes, of course. If you remember, what was the potential energy? Minus P cos theta. Possible? Possible. So this says from 1 and 2, we can say that energy at position A should also be 0. From 1 and 2, we can say that potential energy, energy of the total system to be 0. Gravitation, will do it in the concept by problem session, students. Okay, so stay tuned until end. I'll tell you what is going to be the schedule from tomorrow. So we'll be having different kind of sessions going on. So if you have gravitation, you must be a 2022 aspirant, isn't it? Alright, so from 1 and 2, we can say that the energy at the position 2 is 0, or B is 0, A is also 0. So let's calculate the potential at this point. What is the potential at this point? Potential at position A, if I call this to be position A and B to be that one where the energy was 0, at position A, potential energy is going to minus PE cos theta, where cos theta is how much? Theta is 0 degrees. Okay, so it's going to be minus PE cos of 0, which is going to give you minus P. I told you at 0 degrees it's going to be minus P, least potential. So it's a negative term. Whatever we are doing is fine. Don't worry in your exam. Don't think that what has happened at 90 degrees, how did it come to rest? It is possible it has come to rest with zero energy, because since the beginning the energy of the system was 0. That is when it can attain that, you know, zero energy position at rest. So from this, can we write down something like this? Energy of system at position A has two things attached to it. One is the potential energy part and the other is the kinetic energy part, which is equal to 0. So we can say something like kinetic energy at position A is equal to minus that of potential energy at A, which is going to be, from this equation we can write it down, right? If you take it on the right hand side of the 0, you will get that minus UA. So which is going to be, from this equation we can say it's going to be minus of minus P, PE. So you should have given a kinetic energy at position A to be PE. Okay, you should have given a kinetic energy of PE so that the system comes to that final position at rest at 90 degrees where the potential energy is going to be 0. Where the potential energy is going to be 0. Simple. Final potential energy of the system is 0, which is given to you, so it should be 90 degrees. It has already come to rest, so kinetic energy is also 0. Total energy of the system was 0. At position A, what should be that thing be? Given different, it can be different angular velocity at 90 degrees, then you need to work around it accordingly. What I've done is like taken a case where potential energy and the kinetic energy was 0 after giving some angular velocity to the system at 0 degrees. So energy at position, we said this is to be the position A, this to be the position B at 90 degrees, 0, 0. You understood this part, I believe. So we said that energy at position A is 0, and then we wrote down what is the total energy of the system at position A. Potential energy plus that of kinetic energy. What is potential energy? Potential energy is minus PE, and we found out from this, if we say UA plus KEA is equal to 0, then KEA is equal to minus UA, which is going to be PE. Kinetic energy at position A is PE. 2021, we'll do it as your PYQ series. Okay, I'll take up gravitation as one of the concepts and problem. That way, you know, I'm planning to take up, you know, like some topics that are very important for your exam. Okay, that way. For 2022 aspirants also, the plan is that I take up something that is very important for you. That way, you 2021 aspirants, you can also attend that concept by problem session. Okay, all right, let's get into this final solution. Kinetic energy at position A is equal to minus of minus P, which is going to be P, which is derived that at 0 degrees, when theta is 0 degrees. And it has reached to rest eventually, okay, by conservation of everything that we got this thing, okay. At 90 degrees, we got the total energy of the system to be 0. From that is the reason we got this, okay. It's not just because it is always true, okay. Now, initially the position was 0 degrees. Now comes, what is kinetic energy of the system? It's a rotational motion. It's a rotational motion. From 0 degrees to 90 degrees, it's a rotational motion. So there I can say kinetic energy of the system is going to be half I omega square. Half I omega square. If you remember, what was moment of inertia? Half of moment of inertia into omega square. Okay. So what is omega? Angular velocity, not angular frequency. Yeah, I should have given it a different name. Okay, half I omega square, it's not angular frequency, it's angular velocity. Kinetic energy, this is how you write it. There you write it down as half mv square. Instead I am writing it down as half m omega square. Alright, so now arrives to, okay, now we need to do one more thing. If you remember, what was I was how much, students? What was moment of inertia? 2 ml square, isn't it? Each having mass m. 2 2 ml square, that's it. So this can be written as L is basically 2L is equal to D. This is given in terms of L, given in terms of L. Okay, we are in a safe zone. We don't even need to do it in terms of D. Okay. So there you go. What is kinetic energy of the system? Kinetic energy of the system is going to be from this equation 1 and this equation 2. We can write down kinetic energy of the system to be like half of 2 ml square into omega square, which is going to be how much? Going to be ml square omega square. In this case, it's ml square omega square. In any of the cases, it's going to be ml square omega square. Okay, but be careful while you do it in your exam. However, it is given like energy can be changed due to some work done. So work done is also given. You need to include all of them. Okay, you have 1-star equation. Okay, nothing to remember. This is just a way to work around this problem. Equate them both. Okay, let me equate them both. I think we don't have any space around this point. Okay, I'm going to write it down on a separate page, guys. Okay, just give me a moment. Wrong. What is that? Just give me a moment, students. All right. So what I'm going to do is I'm going to take a small, like a white page and make use of this both equations, star equations, and work around the problem. That's the reason the notes is harmful in this class. Kinetic energy at position is going to be P. From both equations, we can say that it is going to be half of I omega square, which is going to be ml square omega square in this case, where distance between the dipoles was how much? 2L. All right, that's it. That's it. From this both equation, I can find out omega. Omega should be how much? PE by ml square, that is omega square. So omega angular velocity is going to be how much? PE. So what was the angular velocity at theta is equal to 0 degrees? PE divided by ml square, under root of PE divided by ml square. Theta is equal to 0 degrees. Kinetic energy was ml square omega square. Easy? Easy, guys. Easy it is. Okay. Alright. It's done, Jeshwar. Okay. Alright. Answer should have been A. Conservation of energy in such questions. I believe every concept around your dipole is covered. Every concept around your electrostatics is covered. I think you have everything for your JEE Mains and JEE Advanced. We will start with PYQ series on electrostatics anyway, so that you are able to maintain the completeness. But we'll be starting as such PYQ and FYQ series for 2021 aspirants from now on. So be sure to attend it from tomorrow. Tomorrow onwards, it won't be like 2-hour session. It is going to be like 1-hour session from Tuesday to Friday, 7:30 to 8:30 p.m. It's for 2021 aspirants. 2022 aspirants, you can also attend it. We'll be also taking up 2022 topics. But make sure you are on time, because it's going to be only 1-hour length session, and in this it's going to be a PYQ series. PYQ series for your exam preparation coming up in February. So that being said, what about 2022 aspirants? How do you deal and accelerate with your syllabus right now? If you want to accelerate with your syllabus right now, join us on Concepts and Problem series that is going to begin from 6 to 7 p.m. from Tuesday to Friday. So only 4 days a week in December you have to spend on your PYQs and problems and concepts and problems, or concepts by problems. So make sure you are attending them. This is for you students. This is for you. Like, you will be able to progress quickly in your examination. That's why we have this PYQ series. So do attend it. Don't miss it out. The concepts are good. Complete those 25 lectures. Definitely you need to do that. But you know what? Do attend this PYQ series, very important for your examination, so that you are able to understand how you need to work around your exam. I will be also discussing from the exam perspective, also from the concept perspective, if you are moving into new topic. If not, also I will be discussing the concept, so don't worry about it. Do attend it from 7:30 to 8:30 p.m. only 1 hour, and tomorrow at 9 p.m. we will be also having a quiz. Okay, on Prism, be sure to attend it. And right now you can also start with problems and concept series. I recommend that 2022 aspirants do attend both. 2021 aspirants, whichever topic is incomplete, so start attending it for concepts and problem series. Okay, so yeah, do attend it. It's going to be super interesting. Now accelerate your preparation with JEE English exclusively and completely in English. So you can do that, and also with IITians and NITians. So that being said, our team, JEE English team, is going to be live day after tomorrow. That is 2nd of December at 9:30 p.m. 9:30 p.m. we are going to be live, guys. It's going to be Ask Us Anything session, where you can come live to the session and ask us anything regarding to your preparation, strategies, iconic subscription, plus subscription, or anything that you have, any queries that you have in your mind. Maybe subject, but don't typically bring it out to, like topics. You can do that as well, but this is like for your personal motivation, for your personal understanding. You are able to do your preparation. Let's say you're 2 months, you are not feeling confident, do attend the session. I will share my story, Rohit sir will share a story, Abhinav sir will share a story, and also Kaushal Rahul sir will share a story. So come on to this Ask Us Anything question. We have experienced faculty, IITians and NITians on this team. Be sure to attend them. And that being said, the most competitive gamified IIT JEE battle ever, Unacademy Combat, is going to happen again on 6th of December. Enroll today, students, enroll today. 6th of December, mark this date in your calendar. It's going to be a very interesting experience, because it's going to be not only be a competitive thing, also a rewarding thing. What do I mean by rewarding? You can win hundreds of Amazon vouchers, you can win Apple products like MacBook Air, etc. So compete live on December 6th and try to win the prizes. And I'd definitely like to know if someone attending the session are winning the prizes. That would be amazing thing. And not only that, it's not only going to be a fun event, it's going to be definitely a fun event. It's going to be a gamified fun event. It's going to be competitive. It's going to be like one of those like quizzes you're attending, and but with prizes and rewards. Like in quizzes you'll be winning XP points, but here you'll be winning like Amazon vouchers and like Apple products. But it is also going to be a learning event for JEE aspirants. You get to understand and assess your position in your JEE Mains and JEE Advanced. You can put in more work, you can put in less. Don't put in less work at the moment, put in more work or something like that. Or you need to understand which is your weakness, etc. So attend this Unacademy Combat. It's going to be super interesting, guys. It's going to be also not only a fun event, but also a learning experience. The most gamified IIT JEE battle ever. And enroll today with Murli Live Code. Do not forget to do that. And that being said, our JEE English team has started courses for 2021 aspirants on differential calculus, electromagnetism, advanced course on electromagnetism, and basics to advanced detailed course on optics, and also on chemical kinematics. This is for 2021 aspirants. For 2022 aspirants, do we have something? Yes, our team is delivering lectures in English on graph sets and relations, redox and equivalent concepts, and an advanced course on mechanics. And that not only that, our Unacademy team has started Google Batch for Droppers, which has just begun on 20th of November. On 20th of November, there was a Droppers batch which has just begun. So you can still enroll to them and you can start attending them. And for 11th class, micro batch has been started. You can also attend that, okay, from the best faculties, of course, a team of faculties. So that being said, students, do not forget to like this video, do not forget to share this video, do not forget to enjoy your learning, do not forget to attend those PYQ series, do not forget to attend those concept and problem series. You are of course welcome, students. That being said, do share this video, do like this video, because someone in need may get access to this amazing full-length lectures. They can understand the concepts, they can understand the problems, they can attend the PYQ series. So it's like a free of cost initiative by Unacademy, where you get full-length quality lectures for your JEE Mains and JEE Advanced preparation. So do keep sharing them, and don't only work hard but work smart to achieve your success. Do come to our Ask Us Anything event and get your understanding or get your hands around like what you need to do. Avoid gossips, ignore gossips. Of course there will be like many gossips right now. Exam is going to be postponed, this is not going to happen, etc. Do not believe in them. Prepare accordingly, prepare strategically. You can check out my strategy sessions on physics on how to prepare for your JEE Mains and JEE Advanced. I have done a detailed analysis. You can go and check it out. and acquire knowledge and do share it. Keep loving people, and keep smiling, students. And that being said, if you don't have a Telegram app yet, do download it from your Google Play Store and App Store and click on to this link which is available in the description box below. So there is a link in the description box below for our Telegram channel. You can also type in JE_English to find us on Telegram channel. Once you get onto a Telegram channel, you will get what you get live before time updates on every lecture that our JEE English team conducts, either on YouTube channel or on Unacademy learning app. You will get an update like before time updates. You can be prepared for your classes, etc. So do get onto a Telegram channel. We also keep you posted with DPPs and everything. Of course, we will do that. And that being said, Capacitors A to Z series on capacitors is complete, students. A to Z series on capacitors is complete. So do attend those 6 back-to-back sessions to get conceptual understanding, plus 2 additional session was conducted this weekend. You can attend them to, like a PYQ series for your JEE Mains and JEE Advanced preparation. So that being said, A to Z of units, dimensions and measurements is also complete, and A to Z capacitor series definitely an attend topic for your for 2021 aspirants. This way you will be able to score. So one more thing about your notes, what you can do for your notes is you can download them from your Unacademy learning app. So yes, one of the students have been asking for the notes. The reason I'm not giving out notes over here is there are multiple places where we are making use of whiteboard, which is not generally saved. They are like annotated lectures, and I also told you for electrostatics, make your own notes. But the moment the electrostatics will be conducted on Unacademy learning app, you will have your notes. So you can download the notes from there. You can attend the live polls on Unacademy learning app. So that being said, units, dimensions and measurements notes is available, capacitor notes is available, current and electricity notes is available, and soon you'll be having also rest of the notes on Unacademy learning app. And guys, yes, and also annotated, and we will keep on adding pages, and those pages will also be saved. So just to download the notes from Unacademy learning app if you have any difficulty in finding the notes over here. So you can come to Unacademy learning app sessions to download the notes. You can check out my past lectures and download the notes. So yeah, A to Z series of capacitors is complete. Units, dimensions and measurements is also complete. 2021 aspirants, do not ignore this. Definitely 2022 aspirants, you're going to attend them because it's a full length lecture. Complete concepts have been covered in this 4 back-to-back session plus 1 model problem session. But 2021 aspirants, do not ignore the units, dimensions and measurements topic that is being conducted by me on Unacademy learning app, this A to Z series. For that case, do not ignore any of the subjects or any of the lectures that you're following. But that being said, do not ignore this A to Z dimensions, because this is typically one of the mistakes that 2021 aspirants do. So think about it, only 5 sessions and you will typically get 2 to 3 problems every year in your JEE Mains. Sometimes it can also be 2 problems. Sometimes generally it is you'll get definitely 1 problem in your JEE Mains and JEE Advanced. So it's like 3 problems altogether in your session. It can be a little bit more, but this is a very easy topic. It's not only less time consuming, like not only 5 sessions for your JEE Mains and JEE Advanced preparation, but also in your exam it is going to take less time. Easy questions will come from this topic, be it in your JEE Advanced or JEE Mains. So yes, you can attend with all the polls, etc. Go and attend those classes, complete them, students, complete them. It has been conducted on just 4 back-to-back sessions. And that being said, if you don't have Unacademy learning app yet, just do download it from your Google Play Store and App Store. Just type in Unacademy and the first search result is going to be Unacademy learning app, the most downloaded education app across India. And then just click on to this install button. Why do you want to have Unacademy learning app? Once you follow me, you will get live updates on every session that is being conducted by me on Unacademy learning app. And not only that, you can attend national level quizzes. Tomorrow is quiz days. So students, tomorrow is going to be a quiz on Prism. Do attend it, do understand how to work around them. Even if you don't get the answer, it's fine. You can work around them later. So yes, do install Unacademy learning app if you don't have one, so that you can get live updates on classes conducted by me, free of cost classes conducted by me, like A to Z units, dimensions and measurements, A to Z capacitors, A to Z current, electricity, etc. And not only that, students, also you can attend classes from anywhere, and if you follow other educators as well, you will get live updates on them. And more importantly, you can also attend your Unacademy Combat. A very interesting part about Unacademy learning app is you can attend Unacademy Combat and you can also attend quizzes. So do download your Unacademy learning app. So Arish will do a thing for your modern physics. we will take it up in the PYQ series. Any concepts, right? So this PYQ series and concept and problem series is going to be one such series from tomorrow, where it's not just about problems, but we'll be also taking up those concepts and covering it in the model problem session. Okay, so don't worry about it. We'll get started with nuclear physics soon. After during the PYQ series, one of your session is going to be on nuclear physics. But initially we'll get started with those high weight topics. I think nuclear physics also a high weightage topic, so it will be the second one. Okay, second one we'll get started with the PYQs. Now we'll do electrostatics as such. Okay. Alright, so do install Unacademy Learning app. Not only that, if you have an Unacademy Learning app and if you are planning to purchase an Unacademy subscription, or if you already have an Unacademy subscription, you can attend test series and classes from anywhere. So do download Unacademy Learning app, students. Do not miss it out. And that being said, what is Unacademy subscription? Unacademy subscription is the champions tool that you need to excel in your JEE Mains and JEE Advanced. You will excel in your pursuits, guys. So what do we have such that you can excel in your pursuits? We have the best educators across the nation with whom you will be attending daily interactive classes online from anywhere in a structured manner. What do I mean by in a structured manner? Not only that we have best educators, we have the best programs. So we have the structured program where every fourth session is going to be a doubt clearing session. Every fourth session is going to be a doubt clearing session, and that way you will be able to maintain completeness on your preparation or in your preparation. And also not only that, we have dedicated quizzes, mega quizzes, etc. So think about it. It is the kind of the the program that you need for your JEE preparation with the best educators across the nation on a fun platform where learning would be super awesome, and you will love doing it because we have polls, etc. and you will get live polls, live updates on your standings. That way you will be able to enjoy these interactive classes in a very very amazing way. So do click on the left hand top corner extension bar, choose plus, choose IIT JEE as your goal. With this you'll be preparing for both JEE Mains and JEE Advanced. We have programs for both, and then hit on this get subscription button. Not only that, we will not only have the best platform, a very interactive and attractive platform. Not only that, we have best educators across the nation. Not only we do have the best programs, dedicated programs with national level test series going on. So one more important thing about an Unacademy subscription is you have national level test series going on, so you can assess your standing and understand where you are standing right now and what you need to do to improve your overall performance. But not only that, on clicking this get subscription button, you'll realize this, it's not one subscription, it's unlimited number of programs that you have enrolled to. So you can enroll to as many programs as you want, and you can attend as many programs as you want. Guys, it's generally a 2-year long journey, so I recommend that you go for a 24-month program. Typically 8th class, 9th class and 10th class students, you may want to go for 24-month subscription, which comes at a price of less than 2,100. Only 70 rupees a day is what you have to pay for your Unacademy subscription. And do not forget to apply Murlidharan coupon to get the best discount on any of your subscription purchases. To avail best discount on any of your subscription purchases, do apply Murli live code. And that being said, students, you can split your payments into multiple parts using our pay in parts option. Why am I saying this? Using our pay in parts option, you don't have to go through the burden of paying all the fee at once. You don't have to go through the hassle of paying all the fee at once. We also have access to no cost EMIs, easy monthly installments without any interest is our no cost EMIs. So do check it out, and these are two interesting payment options which takes away the burden of paying all the fee at once, and you can split your payments comfortably into multiple parts on month-by-month basis. And we also have debit cards and credit cards and UPIs for your payment options. Of course, Pawan, we will do the gravitation part, okay? And that being said, students, for 12-month subscription, it's going to cost you less than how much? So let's do a thing. So you guys are more interested in gravitation. I've already seen 2-3 students coming up with gravitation. So tomorrow we will be getting started with concept and problem series. We'll get started with gravitation. Okay, if that sounds interesting. I was thinking of starting with mechanics and something else, but we'll do a thing. We'll get started with gravitation. And I was thinking of thermodynamics, students, because thermodynamics carries a lot of weightage. But since you guys are interested in gravitation, we'll get started with gravitation. Don't worry. Okay. But yeah, do give importance to thermodynamics over gravitation. Gravitation is okay. Okay. And 12-month program is for droppers and long term. We have programs for droppers and long term. What do we have? on the table for you. We have not only the best educators across the nation, but we have dedicated droppers batch conducted by the best educators across the nation, 6,000 plus materials for your JEE Mains and JEE advanced preparation, and more importantly, students, we have 100 plus live programs going on so that you can catch up anytime. So yes, this is the kind of thing that you get for droppers as well. You can go for a 12-month subscription, which is going to cost you less than 2,900, only 2,888 per month. So do apply Murli Live coupon to get the best discount on your subscription purchase. If you want to avail the best discount on your subscription purchase, do apply Murli Live coupon. Yes, students, yes. That being said, we also have iconic subscription. So what we were talking about is plus subscription. What we discussed until now is plus subscription. There's something known as iconic subscription. It's an added advantage with the plus subscription. You get India's best educator, daily interactive classes, structured courseworks and programs, and also national level test series and quizzes, along with personal coaching. And from IITians and NITians. So think about it. We have already gone through the journey, and we can guide you and mentor you on what you need to do to crack this exam, and more importantly, what not to do while you are preparing for your JEE Mains and JEE Advanced, and how should you keep your mindset, etc. So you'll have lots of motivational session, personal mentoring. You can get guidance from us, and you can make use of our study planner. You'll have personal study planner. You'll get frequent test analysis on iconic subscription. So this is the kind of thing that you get, and I guess the prices are already effective. Earlier, the 12-month subscription was 50,400 and the 24-month subscription was 77,400. If the price is still that, do avail it. It's worth it, guys. And do apply Murli Live code to get the best discount on your subscription purchase. On any of your subscription purchase, be it iconic subscription or be it plus subscription, be it any of the program 12-month, 24-month, do apply Murli Live code to get the best discount. Yes, do get the personal touch of IITians and NITians during your JEE preparation with iconic subscription. And our JEE English team is also available on iconic subscription, and we can speak in multiple languages so that you can have your JEE workshops in multiple languages. Now you can take your IIT JEE preparation to next level with our personal coaching, with our personal touch, and IIT JEE workshops, expert guidelines, and study planner and test analysis. So we have one of the best teams for your JEE preparation. So be sure to choose our programs as well during your iconic subscription. And I think the new prices are already effective. If not, good. If yes, the prices have been hiked from have been hiked. So it's right now 65,000 for 12-month subscription and 1 lakh for a 24-month subscription. That being said, take care, stay safe, bye-bye. See you in the next class, students. Yeah, do keep practicing. We'll start tomorrow with new concepts. See you in the next class. Take care, stay safe.